Okay, substitution reaction of square planar complexes. As we know, there should be first square planar complexes that should be converted into TBP shape, then again convert into square planar. Okay, but actually there should be in between of two, there should be square pyramidal that should be produced. Okay, square pyramidal that should be produced. So first square planar complex incoming nucleophile that should be attached with it, so it produce square pyramidal shape. Then again this square pyramidal shape converted into TBP shape, then again TBP shape converted into square pyramidal shape, and last one we get square planar complexes which having incoming ligand and leaving group that should be leave from the square planar complexes. Okay, so there must be two pathway can be observed. One is solvent pathway, other is nucleophile. As there is coordinatively unsaturated and electrically unsaturated, so there is no steric hindrance. So incoming nucleophile as well as solvent molecule both can be able to participate in complex formation. Okay. So all these features of the square planar complexes indicate that their ligand substitution reaction should follow simply associative mechanism. Striking features means what? Which I described, that is this. These square planar complexes are tetracoordinate, coordinatively unsaturated, having 16 electron in valence shell, so they are electronically unsaturated, and having p-jet orbital that should be perpendicular to xy plane. Okay, these are the xy plane, and p-jet orbital there should be nucleophile can be attached with it. Okay, so vacant 6 p-jet atomic orbital of platinum, and question number 4, electron count 6, so they are coordinatively and electronically unsaturated. Most of the square planar complexes are studied with respect to platinum 2 due to some reason. First one, platinum 2 complex formation is easy in laboratory. Second one, platinum 2 always produce square planar complexes. Platinum 4 plus produce octahedral complexes, but platinum 2 plus always produce square planar complexes. If we proceed nickel 2 plus, then palladium 2 plus, then platinum 2 plus, so nickel 2 plus can be able to produce octahedral complex as well as tetrahedral complex as well as square planar complexes. That should be depend upon the ligand that should be attached with it. But palladium complex, there should be some variation can be observed. Most of the cases palladium 2 also produce square planar complexes, but platinum 2 plus always produce square planar complexes. So by this reason, we most of the cases we studied about platinum 2 complexes. Okay, next one, the reactions carried out by water or solvent, that is red, that is if both is important, that is solvent and nucleophile, we can combine with it. That should be K1 platinum A3X and plus K2 platinum A3XY. Okay, this is the solvent pathway and this is the nucleophile pathway. Because there should be nucleophile is Y, this rate depends upon also concentration of Y and concentration of initial complex. But as solvent is excess, so in solvent pathway does not depend on solvent concentration, only depend on initial complex concentration. Okay, because when we having any solvent material or any medium material which having large in excess, so they always show their constant entity. Okay, their concentration change is not so variations are there. They are basically, if solvents are excess, so their concentration cannot change so much. So that should be almost we can take it as constant entity, and that's why for solvent control pathway we consider only initial complex concentration. Okay, can be explained by, this is the initial complex. Okay, platinum A3X, for better study, for better understanding, we can say that is all the spectator ligand are A. As we know, spectator ligand means which do not involve in reaction, substitution reaction, but they intact as it is. Okay, they can influence, but they are not direct effect on the reaction. Okay, as we go in nucleophile pathway, so there should be Y attached with it. So it first produce TBP shape, TBP intermediate, and that should be first removal of X minus, we get ultimate square planar complex which having Y in the place of X. Okay, if we go solvent pathway, that is water, as for example, there should be water attached with it and produce TBP shape intermediate. Okay, there should be first removal of X minus, that is leaving group, we get these square planar complexes, and then again the process repeated, that is Y incoming nucleophile attached with it, and that should be the first process. There must be again TBP intermediate produced. So after removal of water, that is also first process, we get ultimate this product. Okay, so what is the difference between of two pathway? In first pathway, there should be nucleophile attached. Okay, sorry, pathway 2, there should be nucleophile attached, and that should be simply produce TBP, and we get the ultimate product. Okay, but pathway 1, there should be two consecutive substitution can be there. In first case, water replace X, and in second case, Y replace the place of water. Okay, so there in pathway 2, there should be 2 times TBP intermediate is produced. 2 times TBP intermediate that should be produced. Okay, so two pathway. One pathway is solvent control pathway. We can say pseudo first order, as solvent is present in large excess, so does not depend on concentration of solvent, as solvent concentration is remain constant. Okay, does not variate. Okay, entirely ligand control pathway, that should be the first order, because nucleophile concentration is matter in that case. Okay, so rate equal to K1 plus K2 if we common platinum A3X initial complex, because both of cases initial complex concentration can be having profound effect. Okay, so we can common platinum A3X, we get K1 plus K2Y. Okay, if solvent concentration excess, on that case we can say, we can also say platinum A3X, that should be much less concentration than Y. So we can omit, we can platinum A3X much less than Y, that is we get rate equal to K observation platinum A3X, why K observation equal to K1 K2 Y. This is the K observation. Okay, where K1 is the first order rate constant for solvent control pathway, and K2 is the second order rate constant for entire ligand control pathway, because in second order, that is in that case the second order, because two concentration are important. This is nucleophilic pathway, and this is must be solvent pathway, there should be only one concentration are important, so this should be the first order rate constant. Okay, this should be the first order rate constant, and this is second order rate constant, second order. Okay, so that is K1 first order rate constant for solvent control pathway, because only depends on initial complex concentration, and K2 is the second order rate constant, that is depend upon both of ligand, entering ligand, and initial complex concentration. We can reduce K1 K2 concentration of Y equal to K observation. By this way, we can say rate equal to K observation platinum A3X. And this is the K observation is the only depends on initial complex concentration. If that is nucleophile concentration is much greater than initial complex, on that case concentration of Y that should be taken as constant. concentration of Y, that should be taken as constant. So on that case, we reduce the overall rate law as K observation, that is K1 plus K2 concentration of Y, that is also now give the constant entity, because concentration of Y, that is large in excess. If suppose concentration of Nicophile if much larger than initial compress, we can take in as concentration of Nicophile equal to constant entity. So we can say that is K1 plus K2 concentration of Y equal to K observation overall constant into platinum A3X. So now the rate is first order, we can better say CO2 first order. Okay, that should be apparently we can say first order, but if we observe this overall rate law, we can better say this is pseudo first order. Okay, if we consider Y axis, and that should be L x axis, concentration of Y x axis, and that should be K observation. So there should be a slope theta, that is tan theta equal to K2, and this is intercept, that is must be K1. If we plot K observation versus concentration of Y, we can say that is Y equal to C plus mx, right? So if Y is x and K observation is Y, so we can say M equal to K2, M equal to K2 and C equal to K1. So that is must be slope is M equal to K2, and that is K1, that should be C. Okay. Now some useful example, we can say platinum Cl4 2 minus. If one NH3 is replace one Cl, we get platinum NH3 Cl3 minus. If two NH3 replace, so we get platinum NH3 whole twice Cl2. Then platinum NH3 whole 3 Cl plus. So these indicate two possibilities. First one, dissociation of platinum Cl becomes difficult with increasing positive charge. When positive charge increasing, on that case, platinum Cl bond will be more stronger. Okay, because more positive character on the metal and Cl is the more negative character, so there should be stronger electrostatic force of attraction. So platinum Cl bond will be more and more stronger. When positive character increases in platinum, there should be platinum Cl bond more stronger. So for break, we need more energy to provide. Okay, so when we produce this compress to this compress, we need some amount of energy, but when we produce this compound to this compound, we need extra more energy. When we produce this to this, then we need most energy than the other, than the two reaction. Okay, formation of platinum OH2 becomes easy with increasing positive charge. On that case, when positive charge increases in platinum 2 plus, as water is not a anionic ligand, water is only a Lewis base. So on that case, platinum OH2 bond formation, that should be more easy with increasing positive charge. As water can be more, there should be more adduct formation when platinum 2 plus platinum having more positive character. On that case, they have more attraction towards the lone pair of oxygen of water molecule. So that's why formation can be easy. Okay. Now some feature, that is there should be the complex X, Y attached with it, so we get this TPP shape. So ultimately C is isomer. Okay. When in that case 2A is cis. Okay. In that case 2A is trans, but there are also 2A cis and there should be 2A trans. So these are the stereospecific nature of the ligand substitution reaction. Cis will be remain as cis and trans will be remain as trans. That should not be changed. Okay. So the reactions are highly stereospecific. Okay. Now always remember that is stereospecificity. Chillet effect is very important. As we know, chillet effect, that is if metal bind with ethylene diamine and metal having, that is NH3 whole 4 2 positive, that is platinum En whole twice is more stable than platinum NH3 whole 4, because ethylene diamine produce ring structure and that should be more stable, and this can be explained by chelate effect. Okay, because chelate effect metal makes more stable complex with ethylene diamine rather than ammonia. Okay, we can say platinum 2 plus. Platinum 2 plus is a soft character. You know HSB principle paper, that is hard soft interaction. Hard means the metal or the positive thing that should be having higher electron, that should be a small size, more positive character, and they are preferable for hard, and that should be combined with hard base. Okay, so hard always prefer hard, soft always prefer soft. Platinum 2 plus is soft. When we go group in top to down, we see that softness increases. Okay, so platinum 2 plus is soft metal and which always prefer soft base or soft nucleophile. If we consider chlorine, fluorine, chlorine, bromine, iodine, that is from top to bottom, softness increases. Okay, so iodine is most soft, then bromine, then chlorine. So platinum 2 plus preferable, that is iodine minus, then Br minus, then Cl minus. Okay, charge is not so important, always charge is not matter, because platinum 2 plus is soft in character. On that case is basically combined with softer ligand, and this should be more favorable. Can be explained by HSV principle. There the charge is not so matter. Okay, now steric factor approach to H2 is very difficult in that case. There should be PET3 and PET3. They are bulky in nature. Okay, PET3 and PET, they are bulky in nature, so to approach in H2O and removal of Cl is much difficult. Okay, because PET3, that is phosphorus, there should be CH2, CH3, and there should be CH2 and CH3. They are bulky ligand. So due to this, their steric hindrance are created. So water when attached and chlorine that should be renewable, there should be approaching of water is difficult. Okay. Now trans effect. Trans effect is the tendency of ligand coded to platinum 2 in a square planar complexes to direct the incoming ligand to occupy a position trans to it is called trans effect. The tendency of ligand coded to platinum 2 in a square planar complexes to direct the incoming ligand to occupy their trans to the position they are respect to their trans place. Okay, that should be called trans effect. And such ligand which directs the incoming ligand to occupy position trans to it is called basically trans directed ligand. So there are some ligands which always show the tendency that the incoming nucleophile when attached with the metal, that should be trans to their position. Okay, this should be termed as trans effect. Application of trans effect, that is the production of cisplatin and transplatin. Cisplatin and transplatin, there should be defined is their orientation. In cisplatin, 2Cl will be cis and 2NH3 that should be will be cis. But in transplatin, 2Cl are trans to each other and 2NH3 also trans to each other. That's why we can say this is cisplatin. All Cl and on ammonia they are cis to each other, and transplatin there should be 2Cl are trans and 2 ammonia they are trans to each other. Okay. So application of trans effect, first one for in that case we use platinum Cl4 2 minus. Otherwise we do not produce. Okay. There always remember trans effect of Cl minus is greater than ammonia. Okay. Here you know that is trans effect of Cl minus is greater than ammonia. Okay. So always Cl give the tendency, that is Cl always direct the incoming nucleophile to trans to it. Okay. If Cl is present in one diagonal of the square planar complexes, it always initiate, that is other incoming nucleophile must be replaced diagonal to Cl. Okay, so there should be NH3 replaced diagonal to Cl. Again, others is NH3 present, that should be diagonal to Cl. So we get overall cisplatin. Okay. Similar, platinum NH3 whole 4, platinum NH3 whole 4 2 plus. There should be all are NH3. So Cl can be replaced in any site. This site. Now Cl having more transcript than ammonia. So Cl, when Cl coming, that should become its transposition. Okay. Cl directs the other Cl minus to its transposition. So we get transplatin. Okay. Now this is the transepate series. That is, this